Big Bertha tunnel boring machine. Big Bertha was built in 2013 and officially launched on July 30th, 2013 in Seattle, USA. It became one of the world's largest tunnel boring machines ever constructed. Big Bertha works by drilling underground tunnels using a massive rotating cutting head at its front. This circular cutter contains hardened steel teeth that grind through soil, rock, and underground materials. As it advances forward, hydraulic systems push the machine ahead, while conveyor belts remove excavated debris. At the same time, the machine installs concrete tunnel segments behind it, creating a finished tunnel wall. Immediately after excavation, this process prevents ground collapse and increases safety for workers. Big Bertha was designed mainly for urban infrastructure projects, especially highway tunnels beneath cities where surface construction would disrupt traffic. Its most famous project was the Seattle Highway 99 tunnel replacement project. Tunnel boring machines like Big Bertha reduce noise, environmental damage, and surface disturbance compared to traditional blasting methods. They allow engineers to build underground transport systems efficiently. Today, TBMs inspired by Big Bertha are widely used worldwide for subway systems, railway tunnels, water pipelines, and underground roadways, representing modern engineering innovation. Bucket wheel excavator. The bucket wheel excavator was first developed in Germany in the early 1920s, with modern, large-scale models appearing around 1950 to 1960. It is one of the largest land machines ever built for mining operations. A bucket wheel excavator works using a gigantic rotating wheel fitted with multiple buckets around its edge. As the wheel rotates continuously, each bucket cuts into soil, coal, or minerals and lifts the material upward onto conveyor belts. These conveyor systems transport excavated material directly to trucks or processing plants, allowing uninterrupted mining operations. Unlike normal excavators that dig in cycles, this machine operates continuously, making it extremely efficient for large surface mining projects. Operators control the machine from a cabin using automated hydraulic and electrical systems that regulate wheel speed, cutting depth, and movement. Bucket wheel excavators are mainly used in open-pit coal mines, lignite mining fields, and large earth-moving projects. Because of their enormous size, some machines stretch over 200 meters long and weigh thousands of tons. Their main advantage is productivity. They can remove massive quantities of earth every hour with minimal manual labor. Today, these machines remain essential in energy production industries where large-scale excavation is required safely and efficiently.
CAT 6090 Hydraulic Mining Excavator. The CAT 6090 Hydraulic Mining Excavator was introduced by Caterpillar in 2012 as part of its ultra-class mining equipment lineup. This massive excavator operates using powerful hydraulic cylinders that control its boom arm and bucket hydraulic fluid. Pressure allows precise yet extremely strong movements, enabling the machine to lift hundreds of tons of material during mining operations. The CAT 6090 works by digging large volumes of rock or ore and loading them directly into mining hall trucks. Its diesel engines generate enormous power, while electronic control systems assist operators in maintaining efficiency and safety. It is mainly used in open pit mines, especially for coal, copper, iron ore, and gold extraction. The tracked Undercarriage provides stability on rough mining terrain, allowing safe operation even on uneven ground. The excavator's design focuses on productivity, fuel efficiency, and durability. Heavy-duty steel construction helps it withstand harsh mining, environments, dust, and extreme temperatures. Modern mining depends heavily on machines like the CAT 6090 because they reduce manual labor and increase material extraction rates. It represents advanced mechanical engineering used to meet global demand for natural resources. NASA Crawler Transporter. The NASA Crawler Transporter was built in 1965 and first operated on May 1965 at Kennedy Space Center, USA. This enormous tracked vehicle was designed to transport space rockets from assembly buildings to launch pads. It works using massive diesel engines powering electric generators that drive traction motors connected to giant crawler tracks. The transporter moves extremely slowly, about 1 mile per hour, because it carries rockets weighing thousands of tons. Hydraulic leveling systems keep rockets perfectly vertical even while traveling over uneven ground. NASA used the crawler transporter for the Apollo missions, including the Saturn V moon rockets and later for space shuttle launches. Today, upgraded versions still support modern space programs. The vehicle's stability and precision are its greatest strengths. Sensors constantly monitor weight distribution and balance to prevent structural stress on rockets. Without the crawler transporter, moving assembled rockets safely would be nearly impossible. It represents one of the most specialized transport machines ever engineered and remains an essential part of space exploration infrastructure. Big Bud Tractor. The famous Big Bud 747 tractor was built in 1977 in Montana, USA, and completed on September 1977. It remains the world's largest farm tractor ever produced. Big Bud works as a high-power agricultural machine designed for deep plowing and large-scale farming. It uses a massive diesel engine producing over 1,000 horsepower, allowing it to pull extremely wide cultivation equipment across farmland. Unlike standard tractors, Big Bud was built specifically for large American farms covering thousands of acres. Its enormous tires distribute weight evenly, preventing soil damage while maintaining traction. The tractor operates by towing plows, cultivators, or seeders behind it. Hydraulic systems control attached equipment, enabling efficient farming operations across huge areas in a single pass. Big Bud significantly reduced farming time and labor costs, making large agricultural production more efficient. Even decades after construction, it still operates in farming exhibitions and working farms. This tractor symbolizes agricultural innovation, demonstrating how engineering solutions can increase food production efficiency and support modern large-scale farming practices. Super Dozer, Komatsu D575A. The Komatsu D575A Super Dozer was introduced in 1991 with commercial production beginning in 1992. This machine is the world's largest production bulldozer. It works by pushing enormous quantities of soil, rock, and debris using a massive front blade powered by hydraulic systems. The dozer operates on crawler tracks, providing stability and traction on rough terrain. Powerful diesel engine generates the force required to move heavy materials efficiently. Super dozers are mainly used in mining sites, large construction projects, land clearing operations, and quarry work. They prepare land surfaces, remove obstacles, and assist in large-scale earth moving. Hydraulic controls allow precise blade movement, enabling operators to shape land accurately despite the machine's massive size. The Komatsu D575A increased productivity in earth-moving projects by handling tasks that would normally require several smaller machines. It remains a symbol of heavy engineering capability and large-scale construction efficiency.